problem based on the determination of calorific value of a fuel sample. So I'll take the first one. Okay, here that is all problem is based on the determination of calorific value. In the first problem, they asked to define the higher and lower calorific value, then calculate the GCV. This higher calorific value is also called as gross calorific value. Okay, it is called as a gross calorific value, higher calorific value, gross calorific value. And NCV, that is a net calorific value of a coal sample from the following data. They'll give some data. In that, they give the weight of the coal sample or the quantity of the sample burnt, that is 0.98 gram. Then weight of water taken in the calorimeter, that is 2600 gram. Then water equivalent of calorimeter, 368 gram. Latent heat of steam, that is 2454. It is actually the sum, it is in terms of kilojoule, it's not this one, kilojoule per kg, it's not this one, kilojoule per kg, that is 587 multiplied by 4.187. You will get 2454. Okay, specific heat of steam is 4.187 and rising temperature is 2.8 Kelvin and percentage of hydrogen is 5.8. Okay. The definition part I will not take. It is the quantity of heat liberated when unit quantity of heat, unit quantity of fuel burned completely in air or oxygen, and the combustion products are allowed to cool to room temperature for higher calorific. If it is escape as such into the atmosphere, that is a net calorific value. Here, the weight of the coal sample, that is taken as a M, and the water equivalent of calorimeter, that is W2, and this is a W1, water. Okay, so higher calorific value HCV we expressed in this way: W1 plus W2 into T2 minus T1 divided by M. Okay, this is a standard equation what we use to determine the higher calorific value of the fuel sample. Now I'll substitute the components. So W1 is 2600 plus W2 is 368. Both should be multiplied by 10 to the power minus 3. So you have to convert gram into kilojoule into rising temperature, the directly given T2 minus T1, that is 2.8. Okay, multiply by the conversion factor, I'll take it here only, 4.187 divided by M. M is equal to mass 0.98 into 10 raised to minus 3. Okay. See, after substitution here 10 raised to minus 3 and the numerator and denominator get cancelled. So that you will get HCV value is 35,505.76 kilojoule per kg. This is a unit use, not calorie per gram. Okay. So we can easily detect the calorific value of the fuel sample. So you can write the higher calorific value formula like this, or in some book they given directly W1 plus W2 into T2 minus T1 into S. They given S. S is nothing but the specific heat of water divided by M. So because when you multiply by a specific heat of water, you will get the HCV in terms of kilojoule per kg. Then they asked to determine the net calorific value also. So the net calorific value is equal to, you know the formula, higher calorific value minus, so 0.09 H, because 1 gram of hydrogen gives 9 gram of water. So that's why the percentage becomes 0.09 into the quantity of hydrogen multiplied by 587 into 4.187, or you can directly take it as 2454, the latent heat of steam. Okay, the higher calorific value what we get is 35,505, 35,505.76, okay, minus 0.09 into, what is the percentage of hydrogen present here? 5.8%. Okay, I'll take this one 5.8 because it already multiplied by the divide by 100. So that's why the directly I'll take 5.8 into 587 into 4.187. Okay, so that is 35,505.76 minus how much this become? 0.09 into 5.8 into 587 into 4.187. Okay, how much it becomes? Anyone? Answer. This same 1282.95. Yeah, is it correct? Hmm? Anybody answered? No one. Why? Huh? So you unmute yourself and answer better. Okay. So I'm not logging on another system. Okay. Here. So you will get this quantity, you will get 1282.95. Okay. So that the net calorific value of a fuel sample becomes 34,224.77 kilojoule per kg. Okay. So this is the final answer. So definitely you may expect one problem from this. Okay. Say first you have to find out higher calorific value. You have to remember this formula W1 plus W2 into T2 minus T1 by M multiply by S. You take it multiply by S. The S value is 4.187. Okay, it is in terms of kilo joule per kg per Kelvin. Okay, here calculate the calorific value of a coal sample from the following data. Okay, they mentioned the mass of the coal is 0.95 gram. The mass of water in copper calorimeter is 2000 gram. Water equivalent of calorimeter 700 gram. Rise in temperature is 2.8. Specific heat of water is 4.187. So from the from this problem, we conclude that you have to detect only higher calorific value. It's not possible to predict a lower or net calorific value because here they are not mentioned the percentage of hydrogen present in the water sample. Sorry, percentage of hydrogen present in the fuel sample. If they mention the percentage of hydrogen present in the fuel sample, then only you can able to detect the NCV. Here, no percentage of hydrogen, so that's why you have to detect only HCV. W1 is 2000 gram plus 700 gram. So multiply by 10 to the power minus 3 into rise in temperature to 0.8 into 4.187 divided by M mass. Mass of the coal is 0.95 into 10 raised to minus 3. So the higher calorific value of the fuel sample becomes 35,073.37 kilojoule per kg. This is the answer what we get from this particular uh, coal sample. Okay. Hmm? So the next one I'll take, okay, calculate the GCV and NCV of coal sample from the following data. Weight of coal is 0.8 gram, weight of water taken is 2000, water equivalent is 800, latent heat of steam is 587 calorie per gram, initial temperature, it should be degree, it is not this one, 25 degrees Celsius. Final temperature is 27.3 degrees Celsius. Percentage of hydrogen is 2.5. Okay. Say first you write the formula higher calorific value equal to W1 plus W2 into T2 minus T1 into S divided by M. Okay. Here W1 is 2000 plus W2 is 800 into 10 raised to minus 3 into here 27.3 minus 25, that is the rise in temperature, okay, into 4.187 divided by the mass of coal, zero point 0.8 into 10 raised to minus 3. Okay, the rise in temperature, uh, rise in temperature, that is 27.3 minus 25. How much it becomes? 27.3 minus 27.3 minus 25 become 2.3. Okay, what is the, how much you got? 2800 multiplied by, it's actually 2800 multiplied by 2.3 multiplied by 4.187 divided by zero point 0.8. So the HCV becomes equal to 34,307.23 kilojoule per kg. This is a higher calorific value of the fuel sample. Now you have to find out the net calorific value. NCV becomes equal to HCV minus 0.09H plus, sorry, it should be multiply, okay, into 587 into 4.187. So 34,307.23 minus 0.09 into the percentage of hydrogen given is 2.5 into 587 into 4.187. That becomes equal to 34,307.23 minus 552.99. So the final answer becomes 33,754.01 kilojoule per kg. Okay, this is the final answer what you get from this on burning this particular fuel sample. Fifth problem. See here, calculate the gross calorific value and the net calorific value of 0.5 gram of coal sample. M is 0.5 gram, which when burnt in bomb calorimeter rise the temperature of 1000 gram of water, that is W1 is 1000 gram, from 293 to 301 Kelvin. That is expressed in terms of Kelvin. Okay, not in terms of see, here it is wrong, not 301, 296.4 actually. Just 296, which is taken as 296.4 Kelvin. The water equivalent of calorimeter is 350 gram. So here W1 and W2 and M both all expressed in terms of gram. That's no problem. The specific heat of water is 4.187. Latent heat of steam is 2457.2. Then coal sample contain 93% carbon, 5% hydrogen and 2% ash. We need only the percentage of hydrogen. We need not to bother about the carbon and ash content. Okay. Say here, I'll take the determination, the HCV first step. HCV is equal to W1 plus W2 into T2 minus T1 divided by M multiplied by S. So that's equal to W1 is 1000 plus 350 Okay, you can take this multiply by 10 to the power 3 into 296.4 minus 293 into 4.187 divided by m value, that is 0.5 into 10 raised to minus 3. Okay, so here it becomes 1350 into you will get 3.4 degrees Celsius, the difference, into 4.187 divided by 0.5. So on simplifications you will get 38,436.66 kilojoule per kg. Okay, so this is 38,436.66 kilojoule per kg. If you are not introduced this S 4.187, if you express in terms of calorie, you will get 9,180. That becomes wrong, okay? Because you have to express in terms of kilojoule per kg, not calorie per gram. This is wrong. You have to express in terms of kilojoule per kg. So what the answer you get, it should be multiplied by 4.187. You will get 38,436.66 kilojoule per kg. Based on this, you can able to calculate NCV, that is equal to HCV minus 0.09 H uh, into 587, or you can take it this one here. They directly given 2457.2. Okay, I'll take the same one, 2457.2. Okay, that is latent heat of steam. Higher calorific value you already is calculated, that is 38,436.66 minus 0.09 into the percentage of hydrogen they given, it's a 5%. So 5 into 2457.2. How much it becomes? It is 37,000. Okay, right. 330.9 kilojoule per kg. Okay, this is a here. It's little different one. See here we take 1.15 gram of coal sample in a bomb calorimeter. The temperature of 3.5 kg of water in the calorimeter increased from 26.5 degrees Celsius to 28.5 degrees Celsius. Water equivalent of calorimeter is if 325 gram. The specific heat of water is 4.187 kilojoule per kg per degree Celsius. The latent heat of steam is 587 calorie per gram. If the fuel contains 4% hydrogen, calculate HCV and LCV. Here, uh, if you observe M value is in terms of gram, that is 1.15 into 10 raised to minus 3 kg. Okay. W1 is 3.5 kg. W2 is 325 gram is given. How to convert into kg? It becomes 0.325 kg. Okay. Now, I'll take first HCV. Okay, you calculate HCV. W1 plus W2 into T2 minus T1 divided by M into, yes, calculate it. Changes W1 is 3.5 plus 0.325. Okay, rise in temperature, what you observed is 26, 27, 28. That means 2 into 2 into 4.187 divided by M, that is 1.15 into 10 raised to minus 3. So you got this much, 27, 27,800 852.65 kilojoule per kg. Then NCV, based on HCV you can calculate NCV equal to HCV minus 0.09 H into 587 into 4.187, that is 27,852.65 minus, okay, how much is 4 into 0.09 into 587, 4.187, that you get 26,967.86 kilojoule per kg. 0.76 into 10 raised to minus 3 kg of solid fuel in a bomb calorimeter, the temperature of 2.5 kg of water is increased from 25 degree, it is not this 25 degrees Celsius to 28 degrees Celsius. The water equivalent of calorimeter and latent heat of steam is 0.486 kg and 2457 kilojoule per kg respectively. Calculate GCV and NCV given specific heat of water is 4.187 and percentage of hydrogen is 2.5. Okay. Here M is 0.76 into 10 raised to minus 3. W1 that is 2.5, W2 is 0.486, all are in terms of kg, no problem. Then temperature 28 minus 25, rise in temperature, multiply by 4.187, okay. How much you get? HCV, W1 plus W2, T2 minus T1 divided by M into, yes, here HCV equal to W1 plus W2 into T2 minus T1 by M. So W1 is 2.5 plus 0.486 into 3 into 4.187 divided by 0.76, because it's all are in terms of kg, into 10 raised to minus 3. So you will get HCV equal to 49,351.50 kilojoule per kg. Okay, this is the answer. In the same way, you can calculate NCV. NCV equal to HCV minus 0.09 H into 587 into 4.187. So this is 49,351.50 minus 0.09 into 2.5 into 587 into 4.187, that becomes 48,969.01. Sorry, 48,798.68 kilojoule per kg. This is the final answer.